I think wasn't it just the positions of the orbits? I think
Right, where it is.
Yeah, and it's one thing that is true about our solar system is that if you get the computer simulations, you can't put more planets in. So if you try and put more planets in, it becomes unstable very quickly.
So the mass of, like, if you measure Mars, you can accurately depict where the next planet close to it would be?
It was. I mean, it was. That's what was done. Was it 17th century or something? I can't remember. It was long. Yeah, and it was just one of those things where you notice a pattern.
Right. They were just trying to figure out what the patterns were.
Yeah, so it's just a pattern, which is, there's nothing to that really, other than to say that most simulations of the solar system, if you put other planets in, they tend to get thrown out by gravitational interactions. So there is a sense in which our solar system has got as much stuff in it as it could have. So the planets are nicely spaced. And you're right, given the mass of them, that depends on how close another planet can be before the interaction goes wrong and it gets thrown out into the intergalactic space or something, because planets do that. We know that planets get thrown out of solar systems by gravitational interactions. So, it points to the fact that solar systems are not stable over long periods of time. They're not like clockwork things. They're not like Newtonian clockwork and it just goes on forever. They're not like that. They evolve, and planets can shift orbits and change. And we know, if you look at the surface of the moon, for example, it's covered in craters, and that was caused. They all seem to hit about the same time, and it's about 3.8 billion years ago or so, and that's called the Late Heavy Bombardment. So we know that if you look at cratering rates on Mars and on the moon, it all seemed to happen in this. Not all, but a big peak around that time. And that seems to be correlated with Neptune moving outwards in the solar system and into the Kuiper Belt, basically, or towards the Kuiper Belt, and causing all sorts of havoc, and everything comes into the inner solar system. So those things happen. But it didn't happen when life was established on the Earth.
So it's all extremely old stuff these shifting took. But how long has the solar system been in this particularly stable situation that's in now?
It's since about 3.8 billion years ago. So if it had been unstable at any point since then we likely wouldn't be here.
Right. Do you think that it's possible? Do you ever entertain the idea that it's possible that we are the only intelligent life in the known universe?
I tend to restrict myself to the galaxy. Right. So I do think it's possible that at the moment there's one civilization in the Milky Way. Wow. And that's us. And I think that's important, actually. And it goes back to what I was saying at the start about the astronomy and cosmology being part of the framework within which you have to think. If you're looking for meaning, or you're looking for how we should behave even politically, that has a bearing to me. I mean, imagine that we're the only place where there is intelligence in this galaxy. And how should we behave? Right. Should we actually, notwithstanding the fact that we're tiny and fragile things and insignificant physically, should we consider ourselves extremely valuable in that respect? Because there's nowhere else where, I would go as far as to say there would be nowhere else where meaning exists in the Milky Way.
Meaning.
Because meaning, it's one of those things that scientists don't talk about very much, although Richard Feynman, one of my great heroes, did talk about it. There's a quote where he says, "What is the meaning of it all?" It's a great essay called The Value of Science. And so what is self-evidently true is that meaning exists here because it means something to us. So that's kind of an obvious statement. Life means something to you and me, and so meaning exists. But I think it is a local and temporary phenomenon. I think it emerges. Meaning emerges from configurations of atoms, which is what we are. We are simply that. We're nothing more than that. We're very, very rare configurations of atoms, I think. And so that means that we are, if you go all the way down that line of logic, we are the only island of meaning in the galaxy.
The meaning only to ourselves.
Yeah.
It means something to us because we're the only ones who can grasp the concept, and we are finite. We are a finite organism. We have this temporary existence while we're here, and to us there is meaning.
Yeah. And I don't know any other way to define it.
Right.
So I'll define it like that.
Yes.
I don't think there's global, otherwise you have to believe there's some kind of global meaning and that's a God type thing. And I don't think I think it's more wonderful and more challenging to us, because we have to take responsibility for it, to say we should operate such that we are it in this galaxy. There's nothing else. I'm sure there are other civilizations out there in the universe, because there are 2 trillion galaxies. I just can't believe this hasn't happened in other places. The question is, how often does it happen, and how widely spaced are the civilizations? And I think they're very widely spaced, and I think there may be 1 or 2 per galaxy on the average. But that, as you said, what you said it beautifully. That what else can we think?
Right.
What else do you want? I mean, I think what it says is you have to take responsibility for all those things, those spiritual things that you think about and the emotional things you think about. You are responsible for that. You are that, right? That, whatever that is, it exists in you, and it will only exist for a short amount of time. And so, make the best of it would be my view.
It's so unbelievably compelling, though, to consider the idea that somewhere out there's another civilization that may be even more advanced than us, and this thought of it is just so attractive. It's incredible.
There should be, if civilizations are common, or even slightly common, then there should be civilizations ahead of us.
Yes.
Because there's been so much time.
But wouldn't you want to see what that's like?
Yeah, I mean, we've been
so
around.
Compelling.
You imagine the timescales. We've been around as a civilization. Let's give it, say, 40,000 years. I don't know how long our civilization has been around. Let's say that. The galaxy is pretty much as old as the universe. It's 13 billion years worth of time. So the idea that there are no civilizations arose, 100 million years ago, 200 million years ago, 1 billion years ago. And imagine what they'd be like if they'd survived. I mean, we've been around, we've had science for, let's say, since Newton or Copernicus, 500 years at most. And look what we've done. We've gone beyond the solar system with Voyager. We've walked on the moon. We're about to go to Mars, I would think. So we're about to begin colonizing our own solar system. So we've done that in 500 years. So imagine 1 million years in the future. So it's one of the arguments often used to say there aren't any civilizations out there in the galaxy. It's called the Fermi paradox. Because if you imagine a civilization that's 1 million years ahead of us, they should have written their presence across the sky by now. You should see them. I mean, you'll see us. If we survive 1 million years into the future, actually even a few thousand years into the future, we will be exploring the galaxy. We will have spacecraft that are going to other stars. We will be doing it. So our signature will become visible, I'm sure, if we